All right, Unit 5 was polynomial functions. So we launched from everything we had with quadratics into functions that have many different degrees depending on the function. This is where we learned about things to the third degree, fourth degree, fifth degree, sixth degree. All of these, when we call them polynomials, all of these functions have certain things in common. The quadratic is kind of the first technically polynomial function that we study, and then we make generalizations beyond that. So some of the key features, first thing we learned about was the degree of a polynomial. We learned how to identify the leading coefficient of a polynomial. Those two pieces of information help us down here to determine end behavior. Remember, the degree could be odd or even, the leading coefficient could be positive or negative, and it has lots of different looks depending on those combinations there. We learned about roots. This polynomial looks like it has 1, 2, 3 roots. Roots can have multiplicities. If the graph kind of turns or bends abruptly right at that root and turns in the opposite direction, we would call it a root of a multiplicity of 2, for instance, kind of that bounce there. So we learned about that for the first time. These polynomial functions will have y-intercepts, and then that's about the end behavior. The next big thing was graphing the polynomial functions, and we would often make sketches just based off of the features that we've listed here. This can tell you a lot about the graph of a polynomial, and then you can just do your best to make a sketch and connect those dots. I remember with you guys giving you all these whiteboards and telling you information about where the roots were at and the end behavior, and you can draw really nice sketches based off of just that information. Of course, determining roots is often easiest if it's in factored form. So this is so important. I took up a lot of the board to write it out. If x is positive a, let's say the number is, 5. Okay, if x is positive 5, a just represents any number. If 5 is a root, then x minus 5 is a factor. Remember, there's that reciprocal relationship there with the signs of roots and factors. It goes back and forth. Linear factors always have this like parentheses x, and then it has a number. If you want the root, you have to change that sign. So that's really important that you know. A few new factoring strategies that you picked up in Unit 5 was the sum of cubes, the difference of cubes. I'd encourage you to write those out again for your brain to begin to memorize them. There is a pattern or structure to how those factor. We also learned how to factor by grouping in this unit, which was super helpful. And it's even helpful with the Unit 4 on quadratics. The next big thing and kind of the ending part of our polynomial functions unit was really another way of factoring. When you take the number 12, for instance, and you divide by 4, you get 3. And 3 and 4 are both factors of the original. So really, this division, this polynomial division, is a form of breaking the original polynomial into its factors. There's two main kinds. You can do long division or synthetic division. I tried to draw pictures there to remind your brain of the difference. Long division, you put maybe this x plus 2 outside. You put the whole factor outside, you put the polynomial here, and you try to keep everything organized as you go across in the long division algorithm, much like 5th grade. Synthetic division is new, and out front here you put a root, not a factor, but a root. So if I wanted to work with this x plus 2, I would need a negative 2 out here because of this big note right here about the opposite kind of reciprocal nature between roots and factors. So that's synthetic division here, and you line up all the coefficients. You're just working with numbers. It takes a little bit of the craziness out of the long division process. I know you guys have done a lot of this in ALEKS, so I assume you can kind of review on your own with what this is. The key idea here, if the remainder is 0, we have a root. You can use this process as a way of testing whether or not something is a root. The remainder, or the output when you do this process, is the y value associated with that original x value. So you can either plug in the given thing that you're considering to be a root and see what the output yields. If the output yields a 0, then we are right here where y is 0. Or just think about the remainder. If the remainder is 0, we again have a root. So this unit was Unit 5. Yeah, I hope this helps.